Hello, this is Joyce from Teaching Growth, and today I'm going to do a quick trig short. This is the first trig short, actually, about the sine function. Now, in this case, when we're talking about trig and sine, we're talking about triangles. And the triangles we're talking about in particular are right triangles. Now, right triangles are any triangle that contains a 90-degree angle as one of its angles. Doesn't have to be bottom left. I just drew it that way. But now, before we can get into what exactly sine is, we have to define what perspective are we looking at for sine. Are we looking at it from this angle? Are we looking at it from this angle? For the purposes of this quick demonstration, I'm just going to say it's this one. Doesn't really matter. I could choose the other one as well. Now, there's going to be three legs we want to define: the hypotenuse, the opposite, and the adjacent. Now, for the hypotenuse, it's literally just the longest side of any right triangle. Just look for the longest leg, the slant. We usually call it the slanted leg, the diagonal one. That one will be your hypotenuse. Now, for the opposite and adjacent, these are where it's dependent on which angle you choose. So we chose this angle. So in this case, our adjacent is going to be, well, the leg adjacent to the angle. And we're going to call it A for the first letter of the word. Now, the opposite, as you may already suspect, is going to be the leg that's opposite to the angle we chose. So this leg will be the opposite. Now, what is the usage of knowing all of this? Now, when it comes to sine, cosine, and tangent, we have this mnemonic that we use to remember, which is SO, CA, TOA. Now, this is where S stands for sine, C stands for cosine, and T stands for tangent. But we're going to be going over cosine and tangent in a later date. Today, we're just being focusing on the SO of SOHCAHTOA. Now, what this means is it lets us remember that the sine of the angle that you're looking at is going to be equal to the opposite over the hypotenuse, or the ratio between the opposite leg and the hypotenuse leg. Now, why is this important? Well, it lets us solve for the legs when we only have one leg and one angle as a variable. Because normally, when you think of solving for another leg of the triangle, you may think of Pythagorean's theorem, right? You have a squared plus b squared equals c squared. But what happens when you don't have two sides given to you? Say you're only given one side and an angle. Well, in this case, you would use sine, cosine, or tangent. Now, this equation can be rearranged much like any other equation. So let's say we wanted to solve for opposite. Well, we'd isolate opposite by multiplying hypotenuse over to the other side over there. So we'd get opposite equals to sine times hypotenuse. And you can do the same thing for h. You could isolate h as well, and you'll get hypotenuse equals to opposite over sine. Now, a property of sine, cosine, and tangent that's important is that you can take the inverse of it, and you'll sometimes see the inverse of sine written as sine to the -1 power of the angle. Now, do not confuse this with 1 over sine. When you see a -1 as the exponent for this function, it means that this is the inverse function, not that it is 1 over the sine function. Now, another way that this is commonly written is arcsine. So these two are interchangeable. Now that we know this, why would we ever want to use it? So let's say that you're given two sides instead. You're given two sides and no angle, and they want you to solve for, well, what would the angle be? So you're given the opposite leg and the hypotenuse leg. Well, we have sine, or SOHCAHTOA, you remember so sine equals to opposite over hypotenuse. And we know this, and we know this. So how do we solve for the angle, or theta? Well, in this case, we would take the inverse sine function. When we take the inverse sine function, it'll look something like this. So what this is an inverse function, and you know what happens when you take an inverse function of a function? They cancel out, and you'll be left with only the remaining internal parts. So you'll get theta, or the angle, is equal to sine inverse of opposite over hypotenuse. Now, those are just a quick overview in the ways that they can be used, but I think the best way to understand sine and all that is to actually do some practice problems. Now, for the first practice problem, it's going to be, of course, concerning a right triangle. Now, let's say we're given an angle theta, and we're told that the sine of this angle is equal to 0.7071, and we're also told that the opposite leg is equal to 5 units. We don't know, 5 inches, whatever. Well, we'll just say 5 units. Now it wants us to solve for the hypotenuse leg. What would the hypotenuse leg be? Well, let's take our equation really quick. So we remember SO in SOHCAHTOA, so we remember that sine of theta equals to the ratio between opposite and hypotenuse, and in this case, they told us it's equal to 0.7071. And we also know that O equals 5, so we'll have 5 over h equals to 0.7071. So when we rearrange this equation and we solve for h, I'll give you some time to do this on your calculator. I'm punching it in on mine as well. So it'll be 5 divided by 0.7071. And we'll be left with 7.07 units for hypotenuse. Now, this is a pretty common question you'll see, and you'll also see, like I mentioned before, finding an angle is a common question. So just be sure to look out for that. I'll be going over more variants of these actually in future videos. Be sure to check out my cosine and my tangent video. They're also trig short, so they're really quick, and I hope you enjoyed. Need any more help or you want to get some tutoring, be sure to check out our Teaching Growth YouTube channel or our center directly because we offer one-on-one tutoring, and be sure to contact us.